students. Today we are going to discuss one more interesting hashing technique or hashing scheme, which is called as linear hashing. Yesterday we discussed about the static hashing and the extendable hashing. Okay, in the linear hashing, basically we use a scheme that utilizes some family of hash functions, like the way it is being shown here, a family of hash function, say h0, h1, h2, that way. Uh, those family can be used where if h0 basically points to some m number of buckets, then h one will basically point to 2m buckets, or you can say in general form, if hi maps to m buckets, then hi plus 1 will map to 2m buckets. It's like, if you increase one bit, like in the previous examples that we have discussed, that is 2 bits means there are 4 combinations, that means 4 buckets can be pointed to by 2 bits, like in a previous extendable hashing we have discussed. Similarly, if we have some 3 bits, means it is just double of 2, 4. So similar concepts is used there, that is, and to identify each of the bucket values, the function used can be of this sort, this one. Okay. So take an example why this function is used here. Suppose if you have a say the number value n, that is the number of buckets, suppose 32, then d0 can be the number of bits that is to represent uniquely each of these 32 values, can be given by 5 bits, right? 2 to the power 5 is 32. So uh, so a0 is basically, then it is h divided by h mod 32. Why h mod 32? Because the value that ranges, 32 values actually ranges from 0 to 31. So each of the numbers can be, if you use mod 32, each of the numbers are uniquely identified, right? Similarly, to identify the 64 bits, 64 different values, it is the 6 bits, right? So it is double of 32, right? So it is 2 into 32, so 64. So h mod 64 identifies each of this number. Similarly, if we just increase one bit here, one more bit, that is 7 bit, then it is 128. So 0 to 127, okay, h value will take 0 to 127, and then mod 128 means each of these values can be uniquely identified, and so on. Okay. This idea is better understood by using the round of splitting. That is, the numbers, basically it's like round robin. It takes a round of splitting from 0 to n. So, uh, and this can be actually, this is the particular bucket which needs to be splitted is always pointed using a pointer next. Okay, so that pointer next actually starts from level 0. Let us take one example, then it will be easier for you to understand. Say this is the initial configuration where you have this 4 buckets, actually one more bucket is here. So these 4 buckets you have, and the level 0 is this one, the first bucket here, which is next pointer initially points to this bucket. Now this 32 means the 20, first we are taking actually the a0, though h1 is here. See, identifying the 4 bucket, the 2 values are sufficient, but you will be writing both the functions. As I already told you, it is represented by family of functions, family of hash functions. So initially those will also be representing the nearest 3 values. So it is basically identifying initially with 0 0, 0 1, 1 0, and 1 1. The simultaneous corresponding values for this 0 0 is 0 0 0, 0 0 1, 0 0 1 0, and 0 0 0 1 0, 1 1. But after that also there are 4 values which basically will only recognize when the buckets are being split. Initially we will just have these values. The h1, as I told you, since it is one more bit, so h1 is basically double of h0, the number of values that h0 can take. Okay, so here initially these are the primary pages or buckets. So n is equal to 4. So level is 0 here. Okay. So next points to the level 0. Now if we want to insert 43, now binary equivalent, the binary of for 43 is written. Now what is the binary equivalent of 43? 43 binary equivalent is basically like last two values, that is the least significant 2 bits are 1 1. Okay, so it basically goes to the 1 1. So 1 1 was already filled in the earlier example that we have discussed. The initial configuration, you can see this is the initial configuration. Okay, so this 1 1 is already filled. So therefore there is an additional bucket which is basically added here. Okay, overflow bucket, you can say, is added, and the value 43 is inserted there. At the same time, the bucket where it was the next was pointing to, it was this bucket. So in the extended hashing, what we have, that in case of when it is full, the same bucket is gets splitted. But here only that bucket which is which is being pointed to by next at that moment of time will get splitted. So here you are using an overflow page to store the value, and the bucket which was pointed to by next was 0. That bucket got splitted. So 32 remain there, because for 32 you have this next 3 level also 0, right? And the rest of the values, the third value, see, last two least significant bit we considered earlier. Now 000 will have this 32 value, because the third bit, this one last bit, is the 0, whereas the other uh, this 44 and 36 are inserted to a new page. Okay, this you can say A2, which is brought to the new page. So basically the first page with the 00 got split, and now those numbers which had the last 3 bit as 100 are brought to a new page, whereas 000 are kept in the earlier page. So that particular page got split, and next point now is incremented to point to the second page. Okay, so the second page here is the 9, 25 and 5. These are the initial values which are stored in the second bucket. Okay, now if we want to insert 37, okay, the 37, the last two binary value is 0 1. So 37 will be basically inserted to the second bucket, second page, 37 here. So there is no splitting because there was an empty space here. So 37 easily got accommodated there. Okay. Now next, if we want to insert 29, the binary equivalent of 29 is also having the last 2 bits as 0 1, most significant bit as 0 1. So it belongs to the same bucket where we have inserted 37. Now when we inserted 37, we have observed that this bucket got full. Okay. So now there is no place for 29. So this bucket needs to get splitted. Now one thing that you remember, there is in the earlier case, the next was also pointing to the same bucket where you are going to insert the 29. This one, you wanted to insert 29 here. So this, the next was 1. So since we have to insert here 29, so this bucket got splitted, but there is no overflow page. Remember, when there is the next pointing to the same bucket, points to the same bucket, which needs to get splitted, then there won't be any overflow pages, because you get empty spaces once you split the bucket. Okay, so the next got incremented and points to the next bucket here without adding any overflow page, and the 29 got inserted. You see the 29, the last 3 bit of 29 is 101. So 29 came to the last page, that's the B2, okay, which is here with the 01 as the last second 2 bit and the 101 as the last 3 bit. So this 537 also has the same condition, so they are in the same page. And the previous one, where you have 01 as the 2 bit and 001 as the last 3 bit are there in the earlier page, means the second position, that is the B page, and the next got incremented by 1 position. Now if you want to insert 22, then 66, then 34, you get a configuration of this sort. Now you can do it yourself and you can check out that when you insert 22, basically 22 got inserted here in the 10, okay, here in the 10. But we know that in the 10, in the earlier page, 40, 32, so there was no space here, 10, okay. So you need to split here, right? So it went there, actually you get uh, this 22 got splitted, and it was with the 14 and 30, because these all had the last 2 bit 10 and the last 3 bit 110, whereas it remained here these values from the initial value. 18, 10 and 14 remain in this particular table here, okay, because they have the last as the this 0, 1, 0 and 1, 0, and therefore the next it got incremented by 1 position, because there was no requirement, it was because it was splitted, uh, and uh, there is no need of any overflow page here, because the next position was pointing to the same bucket where you have to insert that 22, okay. After 22 you have to insert 66, so 66 also points to the same bucket, okay. So there was an empty space here because there was only 18, 10 and 34, so you don't have to split the nodes, so 66 can be accommodated without any doing any splitting and all. So it got inserted here because the last 3 bit of 66 is 0, 1, 0 and last 2 bit is 1, 0, so it will be here in this bucket, even though there is for 10 you have another bucket, but there is it is 110 in the last 3 bit, so 66 won't go to this particular bucket, instead 66 will be inserted in this particular bucket, okay. And after 66 there is 34, so 34, for 34 it is actually last 2 bit are 10 and last 3 bits are 010, so 34 got inserted here, uh, 80. So there was one more space here because 30 was actually shifted here, the last bucket, because 30 has, if you convert 30 to binary equivalent, you get last 3 bit as 110 and last 2 bit as 10. So for the initial configuration earlier, before insertion of these values, it is 66 and 34, 22, 66 and 34. This particular bucket, when you try to insert 22, when it got splitted, this 30, 14 and 30 came to this bucket, right? So there are two spaces here. So when you inserted 66, after that there is one more space where you can easily insert 34 without splitting. So you did not have to split the bucket. Instead, you had to only insert the values here. Okay. So this is how the linear hashing works. Okay. So I think you have understood. You can check out using some more values to insert in the linear hashing table, and this is all about the linear hashing technique schemes. Thank you.